Alright, so I'm going to look at the last one of these formulas on page 18 that we're going to use, and it's the first new one for Leaving Cert that you didn't see at all at Junior Cert. So we've looked at slope, length, midpoint, two of those for equation, but they were nothing new, okay? So you've seen those before at Junior Cert, so we're kind of revising those, sometimes doing a little bit more with them, but we had seen them before. We're going to look at this area of a triangle formula now, which is new. Okay, this last one on page 18 we don't need to know. We don't need to use. So this one here, area of a triangle OPQ, it's a half, then it's got a vertical line, x1, y2 minus x2, y1, and that vertical line again. Okay, so it tells me that's the area of the triangle OPQ. Okay, so P is some point, Q is some point. O, though, if you look at this little diagram here, is marked on as this point. Okay, that point there where the two axes meet is 0, 0. Okay, and that's an important thing about this formula. Okay, and it's a very important thing about this formula. It only works if one of the three corners or vertices in your triangle is 0, 0. So to use this formula, one of the three corners of your triangle has to be 0, 0. Okay? Just to say that we do have another formula for triangle on the course. It's half the base by the perpendicular height. If it's not on a coordinate plane, that's the formula you'll use. Sometimes you'll be able to use that formula on the coordinate plane, but most often if you've got kind of your x, y axis and you're asked to get the area of a triangle, this is the formula to use. Okay, so as I said, that formula only works where one of the corners of your triangle is 0, 0, and that's the situation I have in the first example I'm doing. So find the area of the triangle OAB if O is equal to 0, 0. So that's what I need to happen. Okay, one of my corners needs to be 0, 0. A is equal to 1, 7. So that's up there. And B is equal to 5 minus 2. That's there. So this diagram is rough enough. But that's the triangle I'm trying to get the area of. Okay, so one of my corners is 0, 0. So I can fire away and use that formula I just looked at on page 18. So that formula is area equals a half x1 y2 minus x2 y1. So just like all those other formulas, you're labeling one of your points x1, y1, you're labeling the other one x2, y2. These vertical lines, these operate just like brackets, okay? So whatever you get kind of inside those two brackets, you're going to multiply by a half. The way those vertical lines are different from brackets is if you get a minus number inside there, you're going to change it to a positive. So these are called absolute value symbols or absolute value signs. All right, and they change negative numbers into positive numbers. The reason they're here is area can't be negative. You can't have negative area. So sometimes the formula in here will throw up a negative number, but because area can't be negative, these vertical lines just change it into a positive, and then you multiply it by a half. Okay, so I don't know if that's the situation we're going to get here, but that's why it's vertical lines and not just brackets. Okay, but as I say, formula has x1, y1, x2, y2 in it, so I need to label my points. Okay, you don't use 0, 0, so that's just kind of what you need to use this formula. It's the other 2 points that you label. So I'll call this one over here x1, y1, and this one over here x2, y2. All right, so let's sub into that formula. A half x1 is 1 times y2 is minus 2. So you're going x1 here with y2 from here. Minus x2 is 5 times y1 is 7. And then my vertical line. So like I said, treat these like brackets. So work out everything inside the bracket first. So I've got a half. 1 times minus 2 is minus 2. Minus 5 times 7 is minus 35. all right, which is a half. Minus 2 minus 35, if that's the type of thing which you get wrong sometimes, just put it into the calculator. Minus 2 minus 35, calculator will give you minus 37. Okay, and here we have that situation I was talking about. So area cannot be negative. So what these vertical lines do is they just change that minus 37 into a plus 37, and then they're just brackets again because they've done their job. Okay, now if you get a positive number in there, they do nothing. Okay, so if I had got plus 37, it doesn't change the plus into a negative, it only goes negative into positive. So if I got plus 37 in there, it'd still just be a half times 37. All right, so a half times 37, then if you do that on the calculator, you're going to get 18.5, and then they don't give us centimeters or anything, but it is area, so good idea to write down square units. Okay, but 18.5 is the area of that triangle. Okay, now as I said, you're only allowed to use that formula if one of the three corners, vertices to give them their kind of proper name, of your triangle is 0, 0. It wouldn't be that useful a formula if you could only use it for that really, really small subset of triangles, okay? But luckily there is a way of being able to use it with all triangles, okay? So that's the situation I'm in over here. So find the area of the triangle ABC where A is 3 minus 1, B is 4, 2, and C is minus 1, 3. So my issue here is that I've got three corners or three vertices of the triangle, but none of them are 0, 0. So what I can do is move the triangle. So if I can move the entire triangle, I'm not going to change the size of it. But if I move it, I can move it so that one of the corners is on 0, 0. Okay, so what you're going to do is you're going to pick this triangle up, put one of the corners on 0, 0, and then you're able to use the formula. Okay, you can move any of them onto 0, 0. The one I'm going to move is C, I think. So what I'm going to do is I'm going to move C down there. Now, whatever you do to move C down there, you need to do the same thing. Go on space there a bit. You need to do the same thing to B, and you need to do the same thing to A. Otherwise, you're changing the triangle. Okay, the point of this is I move the entire thing without actually changing the shape or the size of it. So if I move C to there, A to there, B to there, okay, it might look a little bit different because my diagram is quite rough, but idea being this triangle here is the same size as this one, but one of its corners is 0, 0, so you're able to use the formula. Okay, now that's the idea kind of in theory. On the diagram, that's what I'm doing. How do I do that in practice? So what I am doing is I am moving the point C down to 0, 0. So what you're doing there is a translation. All right. So what do you do to minus 1 to get it to 0? You add 1. What do you do to 3 to get it to 0? You take away 3. Okay, so that's your translation, which gets point C onto 0, 0. You add 1 to the x coordinate, you subtract 3 from the y coordinate. Okay, you do the exact same thing then to B and to A. You add 1, you subtract 3, you add 1, you subtract 3. And as long as you add 1 to the x and subtract 3 to from the y, you're doing the exact same translation. You're making that exact same movement. So that means you're not changing the shape and therefore the size of the triangle. So B and A, I'm going to do the same thing. I'm going to add 1 to the x coordinate. I'm going to subtract 3 from the y coordinate. So 3 plus 1 is 4. minus 1 minus 3, again on the calculator, that's the type of thing which you sometimes make a little slip on, but minus 1 minus 3 is minus 4. Over here then, 4 plus 1 is 5. 2 minus 3 is minus 1. Okay, but you see now I've got my 2 points and my 0, 0, so I can fire away and use that formula now. Alright, so I'll call this x1, y1, I'll call this x2, y2, and now it's just like the other example. Okay, so area is equal to a half x1, y2 minus x2, y1. So that is a half. X1 is 4 times y2 is minus 1 minus x2 is 5. Y1 then is minus 4. Let's just be careful with double negatives and stuff here. So this is a half. 4 times minus 1 is minus 4. Minus 5 times minus 4 is plus 20. That's equal to a half on 20 minus 4 is 16. And then the 16 is already positive, so you can just treat these like brackets. Okay, there's no need to kind of do what you did over here and change the sign. So because the 16 is always positive, you don't need to really use the absolute value signs. They just become brackets, and then a half multiplied by 16 is equal to 8. So 8 square units is the answer for that one. Okay, just to say up here, I decided to move C to 0, 0. I could have moved either of the other 2 points as well. Okay, so I could have decided to move A to 0, 0, in which case it would have been take 3 away from the x, add 1 to the y, and do that to the other 2. Or I could have moved B, and the translation there would have been take away 4 from the x, take away 2 from the y, do that to the other 2, and then you'd have 0, 0, some sort of point here, some sort of point here, and plug those into the formula. Okay, but there's your area of a triangle formula. To be honest, I imagine if it would come up on an exam, it will be like this. It won't already have a corner sitting on 0, 0. You'll have to do this translation here. Okay, but I'll give you questions to do where you're doing just this type first to practice it, and then a few of these where you have to do that translation before using the formula.